Okay, so it gets called with positional arguments.
Yep.
But if you name them, it's okay, right?
Yes, it is.
So saying it must have the following signature, well, it doesn't really matter.
All right. It's not really that. All right.
I mean,
But it also could have a positional only one. Okay, I think it's fine. I think we can skip it then.
yeah.
Or we have to word it. All right. I think
Yeah,
we
so
can.
so maybe instead of the signature, you could somewhere in the prose say that it's called with positional arguments.
Yeah, that's better.
Like
yeah.
instead of where, say, the function will be called with 3 positional arguments, or with these positional arguments.
Oh yeah. So like, yeah. I did something similar here. Let me bring it back then. And I will leave the signature of this then. All right, I'll let you know when it's done.
Alright, well, I can also put this on my ever-growing to-do list. And then we can get back to whatever we were doing however many weeks ago. Unless somebody else has something to talk about. So,
was last week's session, was your poster session recorded?
It was not, and the poster isn't shared yet either. I'll have that done next week, because was a little bug that on the poster that I think nobody noticed, but I would still like to fix it before I share the PDF with everyone. But people liked the poster. That was nice.
Maybe I can find a way to present it at some local group here so people can see it as well.
Yeah, I was actually surprised at how cheap it was to print it. Like A0 size. Oh, I guess since you're from America, I can ask you, what's the size you print like posters?
That's a very good question.
Because I printed it in A0, which is pretty normal, but I don't know what the giant paper sizes are like.
Yeah, that's a really good question. Usually, I think giant paper sizes might be European.
Okay.
Because they tend to be industrial. The strange imperial paper sizes are typically for like business letters, correspondence, things like that.
So I think I looked at Wikipedia for paper sizes, and it did show some imperial sizes somewhere, but it looked like a footnote.
I can check with I could easily ask the PyCon people what to do here.
Ledger paper size. Tabloid extra.
Oh, tabloid extra sounds familiar.
But it's it's
that's smaller. Maybe
much smaller than I want.
Yeah, of course.
Okay, so I guess it's either A0 or you just tell the printer and they cut it for you. here it is. ANSI.
Oh, interesting. Never heard of it. Okay.
Yeah. Okay. If you've never heard of it, then it's probably fine to only publish the A0 variant. So, to get back to whatever we were doing, I think I wanted to move generator references out of the syntax documentation, and let's see what my pull request from last time does. So in Stdtypes, I guess that's the place we're moving things into. Oh yeah, this adds the thing about generator generators. So generator types, generator iterators, and then the methods send, throw, close. Then we have asynchronous generator iterator methods. Which I guess should just be called asynchronous generator iterators. Well, because it's the entire API. And this was moved from the syntax docs. So let's see. How that'll work. Once that's built. Search generator at the very end. Okay. So generator types is added. Where is this even? Table of contents. Oh, here it is. Iteration related types. Well, alright, so this whole section is added. This is Python supports the concept of iteration with containers. This is implemented using two distinct methods. These are used to allow user-defined classes to support iteration. Sequences, described below in more detail, always support the iteration methods. How much of this is? Oh yeah, this text was already there. I guess the introduction should say a bit more about the difference between iterables and iterators. Right? Because if we add these headings, this stops making that much sense. So what is the difference between iterators and iterables? We struggle to explain that. Let's see. Oh, I was basically repeating what's already written here, right? Maybe what's here should be in this text and just linked. But I guess what all that's left here is to link the terms. If we're saying described below, we should link to wherever the sequences are documented. Sequence types, types sync. Do we say anywhere that all iterators are iterables?
Let's see. That's a good question. I thought we did. I seem to recall it coming up.
Iterable. Yeah, it's mentioned here. It's probably good to mention it here as well. Maybe I should be leaving these sections alone. Actually, yeah, I probably should be leaving these sections alone. That might
For now, yeah.
One of the things I've started writing before. So let me just had this somewhere in my notes. And revert. So we're leaving this one as it is because it turns out to be a rabbit hole. And this pull request will turn this into iteration related types instead of iterator types, add headings for iterables and iterators, and then add like here is what our changes, right? So let's see what the actual changes. So generator types and everything from here on is the content this pull request will focus on. Okay. Python generators provide a convenient way to implement the iterator protocol, which is just above. Where does this link to? Glossary. Okay. A function that contains one or more yield expression is a generator function, for example. Count to 3. Blah blah blah. Generator functions behave as user-defined functions, which links to user-defined functions somewhere. For example, they have the same attributes. Calling a generator function returns a generator iterator. Okay, maybe we should make it clear that this term is ambiguous. Generator informally used to mean either a generator function or a generator iterator. Right. The term may to what's the wording here? May either generator function or generator iterator. Maybe we should put that here. Python's generators more precisely generator functions and generator iterators. Will that work? Generators, or more precisely generator functions and generator iterators, provide a convenient way to implement the iterator protocol. A function that contains one or more real expressions is generator functions. Count to 3. Generator functions behave as we went through this. So this gives you generator iterator. Iterating a generator iterator executes code of the underlying generator function, producing each yielded value in turn. The iter method, so do we have this produce somewhere? Defined, not really. But maybe that's for the future. Turn the next item. I think we don't. We we aren't already using a different word for this.
Sorry, so for the future, what we need to do is define that the iterator types are iterables?
No, we need to use this word produce.
Produce. Oh, that's right. Okay.
For whatever next returns. Basically, what I want to do is kind of synchronize the terminology, like use ideally use common terms everywhere. It should probably be for something like and or for things like producing, exhausting,
Right. Right.
things driving execution. All of these should use ideally consistent terminology, and whenever we have a set of synonyms we should choose one. But I don't really see a better way to say this in the introduction. Oh no.
Okay, cool.
So iterating a generator executes code of the underlying generator function producing each yielded value in turn. The iter method of custom iterable objects may be implemented directly as a generator function. For example, blah blah blah. So there's a bit of a disconnect. Like this paragraph, like this piece doesn't really lead into this one. Maybe we need a bit more introduction for this. Like one use case, one common use for generator functions is implementing the iter method of custom iterable objects. For example, let's see how that reads. Right now it's more of a additional note at the end of this section. Now, would it be useful to add this to the example? Maybe it's covered somewhere below. Maybe the comment is not necessary. define such a function. Doesn't really say it's a generator function. Is that something to add as an example? Probably not. They behave as regular defined user-defined functions. They have same attributes.
Do we also want to say that basically Python doesn't distinguish?
Right. Well, maybe that's covered here. Maybe we should make it more explicit that this is the only difference. Yeah, maybe even say
oh, I see. Yeah, that's good.
they behave as regular user-defined function. For example, they have the same attributes, except that calling a generator function returns in generator-iterator. Really good enough. Alright, and then we get to generator-iterators. Generator-iterators implement the iterator protocol. Should we relink that? That's this one. Iterators implement the iterator protocol. Iterating them. Guess that's clear what the them refers to, just barely. Drive execution of the underlying generator function. So we already said that we return a generator iterator, and this should maybe link to here instead of to the term.
Yeah, that seems like it kind of double clicks better.
Generator, them drives execution of the underlying generator function. Good. Generator next starts execution of a generator function or resumes it at the last executed yield expression. When a generator function is resumed with the next method, the current yield expression always evaluates to none. And I think this is just stolen from the current generator next documentation, which is in expressions. Like, this is the place we want to remove it from. When a generator function is resumed with the next method, the current yield expression always evaluates to none. Maybe we should also use last executed here to make it clear that we're referring to the same thing.
The same thing.
So I don't know if last executed yield expression, which is in the original box, is the right term, because it's kind of half executed, right? The function is suspended at the sealed expression.
The previous, maybe? Oh, no, I see.
Oh, maybe we should reuse the current. Resumes it at the yield expression. Where the function is
that's very good. Yeah.
Suspended. When a generator function is resumed with the next method, the current yield expression always evaluates to none. And I guess we can also mark up or we can even link yield expression to the actual expression, which should be in expressions. Next yield expression, where the generator is suspended again. We are reusing the word, nice. And the value of the yield list, and the value. This isn't called yield list anymore, is it? That's let's call it the value of the expression after the yield statement. Is returned to the next caller. If the generator exits without yielding another value, a stop iteration exception is raised. Is raised. Let's use the active voice here. Next raises a stop iteration exception. I guess these should all be generator next. I don't know if that links correctly. It does, but I don't think it's guaranteed to always link to the right place. So let's make it explicit. The generator exits without yielding another value. Next raises stop iteration expression. This method is normally called implicitly, for example, by a for loop or by the built-in next function. Sounds good. Let's see, does it link correctly? Ooh, nice. Very nice. Let's do the reference of the for statement. Neat. Does the yield link to a good kind of yield? Yes, nice. Generators have a few more functions. Well, they're methods, right? generic iterators. This subsection describes the methods of a generator-iterator. Well, yes. They can be used to control the execution of a generator function. Well, yes. Control or drive. Let's combine that. Generator-iterators have a few. I want to say something like additional methods on top of those provided by generic iterators, but that's too long. So let's say these additional methods can be used to control the execution of a generated function. So let's say which can be used to control the execution of the underlying function. Note that calling any of the generator methods below when the generator is already executing raises a value error exception. Isn't that true for the next as well? Let's see. If I define a generator function that will return the generator iterators next. Oh, it must yield as well. So I set the generator iterator to the result of the generator function, and then I try to iterate over that. It will say generator already executing. So this really applies to next as well. Does it even apply to close? Yes. So maybe we can leave this note at the bottom here. Maybe we need to list them.
Do you want to make that an actual RST note? Note director?
No, I don't want to make it something. So I like to use notes for things like implications of the document behavior or interesting trivia, things like that. And this is actually part of the actual specification.
Oh, I see. Okay.
Thanks for
Oh, so then it can just be a statement. Yeah. Then it can just be a statement. Yeah, okay.
And I would like to list them because if somebody adds to these docs, they're not likely to check if all the surrounding text still refers to the right thing. and also it's not really obvious that close is also no, it's not explicit that close is also effective. So, generator send resumes the execution and sends a value into the generator function. The value argument becomes the result of the current yield expression, which I think we used before. Great. The send method returns the next value yielded by the generator or raises stop iteration if the generator exits, blah blah blah. When send is called to start the generator, it must be called with none as the argument because there is no yield expression that could receive the value. So this basically repeats what we said for next. So instead of that, I would rather refer to next. Maybe even start with that. Generator function colon. Yes, this is what we mean by that. The value argument becomes the result of the current yield expression. When send is called to start the generator, it must be called none blah blah blah. Okay. Raises an exception at the point where the generator was paused and returns the next value yielded by the generator function. Maybe I should reword this. This method behaves like next. Okay, so I am repeating what I said here, but it's like a very simple summary. And this is a summary I can then reuse for throw as well. Right. So instead of paused,
Yes,
there we use
I'm agreeing with you. Yeah, sorry.
Currently suspended. If the generator exits without yielding another blah blah blah. If the generator does not catch the passed-in exception or raises a different exception, then that exception propagates to the caller. Yeah. I guess we can add that to this paragraph, which should hopefully hint that it's the obvious behavior. Typically use this is called with a single exception instance similar to the way the raise keyword is used. Let's add an example maybe. Oh yeah, we should really add examples to all of these, right? Maybe not next. Or maybe not in this pull request, and we're just trying to move things. Backwards compatibility. However, this this is talking about the arguments. It's called single exception instance. It's similar to the way the keyword, the raise keyword is used. Backwards compatibility, however, the second signature is supported. Following a convention from older versions of Python, the type argument should be an exception class and value should be an exception instance. If the value is provided, the type constructor is called to get an instance. If traceback is provided, it is set on the exception, otherwise any existing traceback attributes stored in value may be cleared. I wonder if this is more common behavior that we could just link to, but I don't know where to look at it. In 3.12, the second signature change, it was deprecated. I don't think we're very likely to remove it, but it might be removed. That's fine. Now close raises a generator exception at the point where the generator function was paused, equivalent to calling throw generator exit. Exception was raised, blah 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 blah. That's equivalent to saying this equivalent. If the generator function catches the exception and returns a value, this value is returned from methClose. So if the generator function is already closed or raises generator exit, by not catching the exception, close returns none. Or maybe let's start by this. Or maybe not. Raises a generator exit exception at the point where the generator function, I should say, is currently suspended. Equivalent to calling throw generator exit. Now, this sentence, the exception is raised by the yield expression where the generator was paused. That's entirely redundant. That doesn't add anything new. It doesn't make anything clearer. Generator function catches the exception and returns value. This value is returned from close. And later we say if the generator yields a value, a runtime error is raised. What? No. Oh, this changed in 3.13 and the new behavior was added, but the old was not removed. So we need to remove it. So if the generator function is already closed or raises generator exit by catching the exception, close returns none. The generator yields a value or runtime error is raised. If the generator raises any other exception, it is propagated to the caller. If the generator has already exited due to an exception or normal exit, close returns none and has no other effect. Which was already said here. I don't think there's much value to saying that it has no other effect. But maybe this wording has already exited. Maybe return is better. So let's try that. So we yield 1, 2, 3, for example. And if we do this and I throw in a value error, then there's no place to catch this exception, so that's always propagated to the caller. I think we should add a paragraph like this. When throw is called to start the generator, we should also say what happens when it says can send non value to just started generator. Huh. That's interesting. I could throw a value error into this. And make an iterator from this. I throw a value error into the iterator. And then nothing happens. Okay, that makes sense. So even if it would have more yields. So the throw stopped it, which is fine. Okay. So when throw is called to the start of the generator, there is no current yield expression that could catch the exception. And what happens? The generator is exhausted, and like so. Next we'll return stop iteration, and the exception is propagated to throws caller. Did we end up adding a term for exhausted?
I thought we did.
At one
I should
point,
probably
right?
look
At one point, right?
Yeah.
Probably didn't make it
Probably didn't make it
yet.
yet.
That's fine.
That's fine.
I'll add it
I'll
later.
add it later.
The exception
The exception
that's
after
right.
That's right.
Value is propagated.
Value is propagated.
This is a keyword. This is a positional only argument, isn't it? Yes.
Yes.
Yeah.
We can just rename it.
We can just rename it.
Let's call it the thrown exception. Make it simple like that. Okay. So does close exhaust the iterator? That's a question here. So if I define the function as yield, then try yielding a different number, except anything. Ignore that anything. Okay, so I'm now suspended to here, so I need to start. Now I'm suspended to here, so I will do that again. Now I'm suspended to here, and I close the generator. Runtime error, generator ignored, generator exit. Right, that is this part, right? So if I need to raise an exception. Okay, that makes sense. Any other exception is propagated to the core. This is good. If a generator is true, this value is returned by close. Should probably say what that did before, right? Alright, so I think we're in a good place now, and we moved this out of the expression documentation. Generator-iterator methods. And there's an example here that I think we'll cover later. do we need to cover the example? Oh, we have examples here. What does this do? Execution starts with... I'll probably leave the examples as examples for the yield expression. We should probably say that close might be called when the generator-iterator is garbage collected. Should we do that? So if we do this try, make an iterator, send none to it, so now we're suspended here, but we get rid of that iterator, and then close will be called when the iterator is garbage collected. So yeah, close should probably when if we should use exit or exhaust. Exit, exhaust. So exit refers more to the underlying function which returns. Exhaust refers more to the iterator, where you're using it as a sequence. So since we're documenting these methods that drive the execution of the underlying function, the exit seems more appropriate, especially since we didn't define exhaust yet and we're not really using it anywhere else on this page, so I'll switch this to exit. Generator immediately exits. So hopefully that's it for generator-iterator documentation, and we can move to asynchronous generator-iterators. Better introduction for these. Do we even document asynchronous generators in general on this page? Object A next. Oh, so asynchronous iterators are defined in the data model. Fun. Maybe we should link that somehow. This subset, is that what the current text does? Yes. Oh dear. Used to control the execution of a generator function. Somebody just copied that and didn't change it, right?
Okay.
So this subsection describes the methods of an asynchronous generator solution which are used to control execution of an asynchronous.
I see.
Okay, so
what are we up against? A next returns an awaitable, which when run starts to execute the asynchronous generator or resumes it at the last executed yield expression. We used something else here. At the yield expression where the function is currently suspended. When an asynchronous generator function is resumed, an anex method, current yield expression always abides to. So we should just copy this, but change it this time, right? None in the returned awaitable. Okay. Which will, when run, continue to the next yield expression. Guess that's this part. value of the yield list, well, it's not yield list now. Value of the expression of the yield statement is the value of the stop iteration. Oh, we shouldn't have used statement up here. Keyword. Is the value of the stop iteration exception raised by the completing coroutine. This is a bit more complicated. If the asynchronous generator exits without yielding another value. So this was obviously inspired. Awaitable instead of raises stop async exception. Signaling that the asynchronous iteration is completed. Oh, this signaling is nice. You can add that up here. Okay, so I guess the original was pretty good after all.
Yeah, it's nice to know that. Do we need to define, do we need a term for awaitable? Is awaitable a thing?
Well, I hope we have a term for that. We do. Oh, good. That's a thing, yes, thank you. After the yield keyword. It's the value of the stop iteration exception raised by the completing coroutine. The asynchronous generator exists without yielding another value. The awaitable instead raises a stop async iteration exception, signaling the asynchronous iteration is completed. So we do have an aNext function, right? Yes. Right. Let's merge this one next. So that would be the send, and maybe we need this little blurb as well. So this returns an awaitable which when run sends a value into the underlying asynchronous generator function. The value argument becomes the result of the current yield expression. And now we say otherwise this method behaves like agent a next, resumes the underlying function and either returns the next yielded value or raises stop iteration. Return is a bit iffy here, so let's see this wording. As with the generator send method for a generator, this sends a value into the asynchronous generator function, and the value becomes the result of the current yield expression. Yep. The awaitable return by asend.
On 1175, should sends be capitalized?
Oh, no, thanks.
And also maybe on 1161? I can't figure out if it's literal or...
Oh, I'm getting rid of these.
Oh, okay, forget it.
This part.
This part.
Yeah, okay, got it.
That's just reference. So it behaves like a next, but it's more complicated now. It returns, or it's already, we already say returns unavailable. So when the returned awaitable runs, it resumes the underlying function and returns the next yielded value or raises stop. Return the next value. Oh, that's the value of the raised stop iteration. Oh. Returns the next yielded value as the value of the raised stop iteration, or raises stop async iteration if the asynchronous generator exits without yielding another value. That's here, right? Yes. So it's now 4 lines, but it's smaller than repeating everything. And now this, when asend is called to start the asynchronous generator, it must be called with none as the argument, because there's no, yeah, so this is the same as before. Nice. And then athrow. So athrow should mirror whatever we said about throw, except more complicated. So let me add the reference again. So it again returns an iterable that when run raises an exception at the point where the underlying asynchronous generator function is currently suspended. You know, async await is not just worthy in the source code, it's worthy in the docs as well. Raises an exception of type at the point where the asynchronous generator was paused. Okay, and returns the next value. So let's copy this part. Otherwise, this method behaves like agen.a next, it resumes. It's this, right? And the return awaitable runs, it resumes, blah 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 blah. This. The generator function does not catch. No, this is this. If the underlying function does not catch the past an exception or raises a different exception, then so run, that exception propagates caller of the awaitable. Okay, and then we do this. And typically use this is called with a single exception argument. I changed this to exception before, but I should really, if I'm not changing the documented signature, I should keep the wording this had. Single exception instance. Say single argument to make it clear that we're talking about the arguments. An exception instance, similar to the way the keyword raise, the raise keyword is used. And here we can say the same thing, and then for backwards compatibility, the second signature is supported. And link back to exception instances created from the arguments. In the same way as in, and that would be normal generator throw. Right, argument handling is exactly the same. Let's see how that reads. Oh, I left in the reference, so this goes out. Oh, and I'm missing the part I added. Right. when it's called to start the generator. So when athrow is called to start the generator, the generator immediately exits, that is subsequent. Not immediately. That's exits when the awaitable runs. That's we probably don't need to say what that means, because it means subsequent calls to a next will return awaitables that will raise stop async iteration when run. Maybe we can word that in a normal way. Subsequent results from agen.anext will raise stop async iteration when run, and the thrown exception is propagated to the awaitables caller. And I should probably make sure that is what actually happens. So how do I do that? Async def, here's my function, it will yield a value, and then when I call this, I'm creating an asynchronous iterable that I should call anext on, and just save that. That's the awaitable, so I'm just saving the result here, and I now need to await that. How do I do that? Wait, no. Did I forget my async? Oh, right. The next will raise a stop iteration. Just for the awaiting. So now that has caused this function to be suspended at this yield, and when I make another one, so this one should be exhausted. Yeah, cannot reuse already weighted. Next asend. So now I set another one to this. I see what its value is, and it stops async iteration. So all that we've written here actually works. And you wanted to ask a question, right?
No, I'm good. Thank you.
Are you good? This is a bit mind-bending.
It's dizzying. Yeah, it's mind-bending, yeah.
Right, now for this statement, when athrow is called to start the generator exits when the awaitable runs. So make a new async iterator. It's just started, so it's stopped right at the beginning. And we want instead of a next, we want to athrow something like a value error. Boom. Right? I forgot to set the variable. So now when I see what happens here is the thrown exception is propagated to the awaitables caller. So this is the same wording as before. But what happens when I get the next value here? I get a stop iteration. So the generator exits. Subsequent results from a next will raise stop sync iteration when run. And thrown exception is propagated. So everything checks out. Just like a layer of interaction to everything. Okay, we're good here. Next up is the aclose. So let's so this is just like a three-way merge and get. We have the original text and we have the new text. We need to merge them. So aclose returns an awaitable that when run will throw a generator exit into the asynchronous generator function. Even put underlying just to pad the word count and the point where it was. Let's reuse the wording here where it is currently suspended. Equivalent to calling athrow generator exit. And please you have a bit of an echo on your side.
Sorry, I'll fix that.
Thanks. If the asynchronous generator function then exits gracefully, what is exits gracefully? Is already closed, or raises generator exit by not catching exception, then the return awaitable will raise a stop iteration exception. Any further awaitables returned by subsequent calls to the asynchronous generator will raise a stop async iterator exception. This is nice wording.
Indeed. I sadly need to run off to drive to my next appointment.
Alright.
So I'll drop early, but thank you so much.
So let's stop here. Add a big to do. agen.aclose, and see you next week.
Thank you.
No, I'm already here. So I'll push this and we'll continue next week. Thanks for your attention. I think this is working out rather well, given the mess we're untangling.